should DL stand for? Deciliter. Not to be confused with which other abbreviation. Deciliter. All right. What's the SI unit for mass?
Kilogram.
Kilogram. What do you suppose most people want to pick on the test?
Gram.
Yeah, they want to pick gram a lot, so don't get that one confused. All right, that one's a kilogram. All right, so number 4, 5, and 6 are like the homework questions that I gave you. All right, so in number 4, you have 125 grams. We're going to kilograms. So 125 grams. What goes on the bottom line? And what goes on top?
Kilograms.
All right, so King Henry died by drinking chocolate milk. Who's bigger?
Kilogram.
All right. Now, several of you asked me where gram is on this chart. Remember, meter, liter, and gram sit on the baseline. Okay? So, if they all sit there, how many spaces between kilo and gram? 3. 1, 2, and 3. So that means 3 zeros and a 1. So just calculate, we do what? So 0.125 kilograms. Questions about the first one? All right, number 2. We had 35.6 decimeters, and we're going to millimeters cubed. All right, 35.6 decimeters cubed. We're going to millimeters cubed. So decimeters cubed on the bottom, millimeters cubed on the top. All right, who's bigger? Okay. So decimeter here. And how many spaces between deci and milli?
2.
So 2 zeros and a 1. And what are we going to do that makes this chart and this chart different? All right, both of these have cubed units, so I cube both of the numbers. Does everybody see how those are different? Okay, are we okay with calculating this? Now, did you get your own calculator? Because I need mine. All right, so if we say 35.6 times 100 raised to the third, we get an answer of 35,600,000 millimeters cubed. Everybody okay with that? I think I counted all the zeros right on the calculator. All right, and the last one was 28.7 liters to centimeters cubed. All right, so liters to centimeters cubed. What are we supposed to remember about a centimeters cubed? It equals a milliliter. So if I want to go liters to milliliters, all I have to do is 28.7 liters to milliliters. Who's bigger?
Liter.
How many spaces between?
3.
Yep. Oops. So liter is here on the baseline, and we're going to milli. So 3 spaces. So 1, 2, 3 zeros. And so what am I doing to calculate this time? 28,700 milliliters. Questions?
What if you centimeters cubed?
Oh, yeah. And you should, because that's what I asked for, was centimeters cubed.
I did the same.
Any questions? Now, under your opening, I would just draw a line so that tomorrow you can write opening number 2. And some of them will be shorter than the one we did today. Okay? Now, all of the stuff you just practiced would be fair game for the quiz tomorrow. Okay? Any questions about that? All right. Let's talk homework answers. All right. That'll be in this notebook. All right. Question number 1. Should have an answer of 0.0156. So decimal 0.0156. So 0.156. Everybody got it? And then a meter at the end. Nobody forgot their M, right?
At this time, we need all freshman teachers to accompany their class into the auditorium. We need to come in and fill in all the seats in the front. If you have some students in your class that are not freshmen, they still need to come with you. If you have a question about whether you should come or not, please call the office. But if over half of your class is freshmen, then you need to bring your entire class. Thank you.
How many of you in here are sophomores? I have one sophomore. How many of you are juniors? Okay, so we'll go to the junior meeting if it's called during first period. Okay. I just wanted to know. I do not know when the junior meeting is. I don't know if it'll be first or second period or what day of the week it is. All I know is the freshman meeting's today. All right. Number 2 is 1.25 hectometers. Number 3, 0.35 decameters. 0.35 decameters. And you don't have to have the 0. I'm just emphasizing where the decimal is. Number 4, 650 hectometers. Number 5, 16,840 millimeters. So 16840 millimeters. Number 6, decimal and 3 zeros, 156 kilometers. A decimal and 3 zeros, 156 kilometers. Number 7, 15.6 centimeters cubed. And the last one, 956,000. So 956 and 3 zeros. 965. I flipped my numbers. Sorry, I flipped my numbers in the answer. 965. Numbers. 965 and then 3 zeros. I think I should fix my key. I haven't flipped. Questions about any of the 1 through 8? No? Everybody got all 8 right. So if we do any of those on the quiz tomorrow, we know what we're doing.
Yes, ma'am.
Okay. All right. In that case, let's talk about using scientific notation, because I have tried to stick with questions that did not have large or small, really small answers. But, you know, I have to keep calling out these 0.000 numbers. I hate doing that. So let's talk about how to use scientific notation on your calculators. Now, somewhere in your, does everybody have a calculator, first of all? You have a calculator? We'll get one. All right. Somewhere in your math background, you should have worked with scientific notation. And so we're going to learn how to use the calculator to do this. I'm going to give you a basic rundown of what it is, but we're going to use the calculator to do this. We're not going to spend time moving decimals today other than to explain what it is. First of all, scientific notation is used for very small or large numbers. So, instead of me calling out a number like 956,000, like I just did a second ago, we would put this number in scientific notation. Okay? We would not call out 956,000. So, where do we know the decimal is in this number?
Behind the last 0.
Behind the last 0. Okay? It has an understood decimal. And that understood decimal is right here. Okay? Everybody knows it's there. You learned it was there, I don't know, somewhere in early elementary school. I'm going to guess 2nd or 3rd grade. So, if you know the decimal is there, we get to move that decimal. Scientific notation is designed to be a number between 1 and 9, a decimal, And then any number of numbers you want after that, times 10, and then an exponent. So, if I have to have a number between 1 and 9, how far do I have to move that decimal? Well, if I stop the decimal here, is 956 a number between 1 and 9? No, that's way too big. If I put it behind the 5, is 95 a number between 1 and 9? No. So I have to move this decimal all the way to between what?
9.
The 9 and the 5. Because 9 is a number between 1 and 9. So I'm going to change this number to 9.56 times 10. Now, the exponent is the number of places we move the decimal point. How many places did I actually move the decimal? 1, 2, whoops, my eraser got too close. 3, 4, 5. I moved it 5 places. So the exponent is a 5 because I moved it 5 places. Now, if I move it 5 places to the left, it's a positive exponent. If I move it to the right, it's a negative exponent. And because I moved it to the left, it's a positive 5. Okay? Somewhere in some math class back several years ago, you probably did this. My guess is like Math 1 or middle school. Okay? I don't know where, but somewhere in your recessed math classes, you did this. Does it look familiar? Okay. It shouldn't be new. We're not going to spend time doing this. We're going to let the calculator do the work. I'm just talking about where it comes from. Everybody have it? Okay. I see a couple heads nod no.
Wait for it. No. You gotta put like tape or something on it.
That's what I was gonna do.
Okay.
Got it? All right. So let's say that we have 0.000154, which is similar to another number we had in the homework. All right. This is a small number. This would be another one we would want to put in scientific notation. I'm not saying you have to put all of your answers in scientific notation, but those that are really small or really large should be put in scientific notation. So again, look at where the decimal is. This one's not an understood decimal. This one's actually written. So the decimal is here. Where does the decimal need to be? After the 1, because the 1 would be the number that's going to be between 1 and 9. So 1, 2, 3, 4 places. So 1.54 times 10. How many places did I move it?
4.
I moved it 4 places. This time I moved it
To the right.
to the right, so I make it a
Negative.
negative. Now, that's how it works. But again, if you can't do it, what can do it for you? The calculator. Now, we want to be able to use scientific notation with a calculator. That's where our emphasis is going to be today. So, does everybody have one in front of you? All right, let's say that we want to do a problem such as 4.58 meters cubed, and you're going to change it to centimeters cubed. All right, and we want to be able to write the answer in scientific notation. So, say that tomorrow in the quiz that I specify the answer has to be written in scientific notation. So, how are you going to do this question? What you going to do on the quiz tomorrow?